Ya Allah, lagi cikgu yang aku tadi. Ya Allah.
Boleh simpan sikit space nak. Tak ada nak ambil attendance je ni.
to the topics. Is okay. I think we should discuss about the e-test next week, and I happen to know that you are going to have another test. Is that right? On the same day?
Doktor sudah tukar masa.
Huh?
Subject line tu sudah tukar masa. So available untuk next week exam.
Okay, so all of you available next week, right?
Yeah, doctor.
Okay, then we just proceed with the original idea. So we are going to have the e-test next week, the same time, the same day, Monday, 2 until 4. And the topic will cover chapter 13 and 16. Okay, and also for your lab report, I already post the information. Actually, I just got it from the textbook, but I think it's fine because actually I'm not measuring the your skill for this course. It is just a report, not the teamwork. So I think it will be fine if we just use the data from the textbook only, and I don't see much different. So I already posted the information regarding the lab test, and I hope you can come up with the lab report for direct shear test, consolidation test, as well as triaxial test. And each group just submit one report, and the time actually is flexible as long as you submit during this semester, even until final, before grading. I would say even during the final weeks also it will be fine, final exam week. So since we don't have the final exam, so you may have time to do it, or actually it's better if you could just finish it before the exam, or do it the latest by your review or your weeks. You have a break for 1 week before the final exam, then I think by that time you should be able to finish the lab report. What you can do, you can just distribute the workload. You have 5 members in a group, then just distribute the load. So yeah, that would be a good idea for you to finish the reports soon as possible. Yeah, is there any question regarding the lab reports? Okay, if you don't have, then we can just proceed for the material. And also you can ask me regarding the e-test also. Okay, for this chapter 16, it is about the soil bearing capacity of shallow foundation. Okay, normally we design, or we when we want to construct foundations for any building, so we first of all we need to know what is the soil. To do that, we need to do, we call it site investigation, where we bring equipments to the site, and we do boring tests. I mean, we try to get the soil sample for every meter of the soil, and we get the sample, and then we take the sample and bring it to the labs, and then we do some tests such as limit Attribute limit test, compaction test, direct shear test or triaxial test, and as well as the consolidation test, so that we can get the soil parameters. And then when we get the soil parameters, only then we can design the foundation. So this topic is about the foundation, and normally to design the foundation, we need to know what is the soil bearing capacity, what is the how much the load that the soil can sustain, or how much the soil can take the load of a building. So normally by this time you should have already the structure design, so you know which location is the foundation and what is the load for each column, so you know where is the location of the column. So then when you want to get the sample of soil for you to bring to the lab, you already know what is the location of the foundation, so easy for you. In normal practice, normally we try to get the sample, soil sample, which is under the columns, the main column, and the most critical column, which is the largest in values. For example, maybe 300 kilonewton. Then we know what is the roughly the load that will be imposed on the soil, and only then we could do a better or more accurate lab test, because we know what is the pressure that will be applied on the soil. So our test, for example, direct shear test, so the load should be in the range. When we test the soil, let's say it is a 300 kilo Pascal, for example, and then the soil, we should test at least have that value 300 kilopascal for that sample. Then we would get a better soil parameters. So normally that is how we do it to get the soil parameter. But for most textbook, for the problems, we are already given the soil parameters. For example, we already know what is the unit weight of soil. We already know what is the C value, cohesion, and we already given the phi value, the internal angle of friction of the soil. Normally those we get it from direct shear test, and also if we want to be more accurate, we use triaxial test. And from consolidation test, we can get the pre-consolidation pressure, PC. So and also we know the E value, Young modulus of the soil. So from that, we can do the design for the foundations. Okay. Okay. For this, in this textbook, normally we are given all those values. And here we would like to know the theory. Okay. Okay, for example here, okay, bearing capacity for shallow foundation. Okay, normally when we design, we don't know whether we are going to do a shallow foundation or deep foundation. Generally, we just based on the type of building, for example, maybe a 4 or 5 uh, uh, story building, even some, if the soil is good, we can just use a shallow foundation, not a deep foundation. Deep foundation is like pile, where we can see a lot of construction for high-rise building. They're using pile, and for shallow foundation, we are talking about a shallow, not deep foundation. I think there is a type of shallow foundation. We think there is also mentioned in this textbook. So, okay, we go straight to the topics. Okay, normally we want to know whether the soil can take the load of footing or columns or not. And we would like also to know the settlement, how much the soil settle. And then from that, then we would know whether the foundation is okay or not. Whether we want to have a shallow foundation or we are going to have a deep foundation pile. Okay, so here it say, for example, the file. Okay, let me get my highlighter. Okay, okay, for pile and some they call it drill shaft foundation. Normally for heavier structure, more loads, or we can say high-rise building. So we need to have a pile foundation. For small building, for example, 2-story building, bungalow, normal one. If the soil is good, then we don't need to have a pile. We can just have a spread foundation or pad foundation, mat foundation for footings. Okay, this is spread footing, for example, like this one. This is what normally we have in Malaysia for bungalow. And then we have a mat foundation, normally several columns will be handled by just one footings, and we call it a mat foundation. And this is for pile. Okay. For C is a pile. This is for heavy structure, where the load will be taken care by the friction between the pile as well as the end bearing. At the end here, the tip here, also carry load, as well as the skin friction. They call it skin friction. So here, we need to calculate what is the skin friction as well as the end bearing here. But most of the time, normally, when we do pile, we socket it to the bedrock, meaning that the pile goes until the bedrock. and the pile sit there. We anchor there so that the weight of the structure will be transferred to the bedrock. So in that case, some they just ignore the skin friction. But in a case where the soil is so deep that we can, it's difficult to get to reach the bedrock, then we design the pile using the friction or skin frictions. Okay, so and the other one, this one is the drill shaft foundation. So this is how it look like. So it will take the load at the bottom part here as well as the friction. But here, the bottom part has more area to cater for the loads. So roughly that is how we decide uh, whether to use a deep foundation or shallow foundations. Okay, we need to know what is the ultimate bearing capacity. Ultimate bearing capacity, how much the soil can sustain the load of the building. Okay, the ultimate is the highest one. So what is the highest, I would say, strength or capacity of a soil to bear the structure, the weight of the structure? Okay, here we can see here, normally let's say this is the foundation and this is the soil, and if there is a load on top of the foundation or the weight of the structures, so through time we will see there will be an increase in settlement. Settlement will increase. So the value will increase until a certain point. For example, 1. So that is the general shear failure, we call it. If it goes as if there is no peak, then that is a local shear failure. So here it is important to know what is general shear failure and what is a local shear failure. General normally it reach to the peak. Local still progressing. It's still progressing. Okay. And we can see here part A here, not part A, yeah, here for A, this is the general shear failure where let's say this is the foundation. When there is a load on top of it, the soil will settle, will move downward, and then it creates as if there is a triangle under the foundation, which is the area 1. And then the soil, as if it is pushing the soil, the foundation is pushing the soil until there is a shear along the envelope here. So it creates the area 2 as well as area 2 the other side. So it is symmetrical. So it is push the soil until we can see there is like a bump here. The soil displaced, and the area, this part is a part 3. So here we can see this is the general shear failure. And part A for B, this is the local. Local means it still hasn't reached to the surface of the soil. There would be a buckle or there is a bump on the surface, but the soil is not reaching yet, it's still progressing. So that we call it local shear failure. So this is the concept. So you need to understand there is a general shear failure and there is a local shear failure. Okay. And then we been introduced to Terzaghi ultimate bearing capacity equation. So this is a well-known method how to calculate the ultimate bearing capacity. So Terzaghi and being used by practicing engineer in calculating the bearing capacity. So the issue is, for example, shallow foundation like this one, and here we introduce a depth or the depth of foundation. So from the bottom until the surface of the soil, and that is the depth of foundations. And this equation actually is based on this triangle where they calculate to find the equilibrium of forces between the external forces and internal as well as the shear force. And by using that concept, then they come up with the bearing capacity equation. Terzaghi come up with the bearing capacity equations, where you can spend your own time to look at how they derive it. So what is important here is this one, for example, the bearing capacity equal to CNC plus QNQ plus half gamma BN gamma. So here the value NC, NQ and N gamma is given by equation 16.5 until 7. So this is the equation. At the end, you come up with the bearing capacity, ultimate bearing capacity, U ultimate, according to this equation, where C is the effective cohesion and Q is the surcharge or given, and B is the width of the foundation. So here we can have the equation. So we can calculate the bearing capacity using this equation. Okay. And at the end, yeah, like this one. So we need to consider whether there is the foundation is square or circular. Okay, for square, the equation is like this one with a 0.4 instead of 0.5. Normal one 0.5 or half. But the only difference here, they put the 0.4 and 0.3 coefficient for C here, the first term. And this one is 0.4. So if it is a square foundation, use this equation for ultimate bearing capacity. Okay. And here it is given. For example, we know what is the value of phi, angle of internal friction, and from that we know what is the NC, NQ, and N gamma. So we can use this table to get those parameter values. And for circular footing, here 0.3 here for equation of ultimate bearing capacity. And then B is actually not the width now, but it is the diameter. So you need to use the right equation for the right type of footing. Okay. And then for strip footing also given and others. Okay, so the idea is that you need to know what is the type of footing, whether square or circular, and then choose the right equation for ultimate bearing capacity. And here is when there is a groundwater table. So there are few cases here. Case when the groundwater level above the foundation. The case B when the water table is exactly below the foundation. And also the condition C where the groundwater table below the foundation. So they call it case 1 until case 3. So you just need to use the right equation here. And also important what to get the value of D half. D half here is the height between the below the foundation until the surface of soil. So and then you can use the equation given for those three cases. And to calculate the factor of safety, which is very important in design of foundation, factor of safety normally use about 3 or more, meaning that if you design the foundation, actually it can take 3 times it is 3 times stronger than what it used to supposed to be. So you triple the maybe the strength 3 times. So in that case, it is less likely that the building is going to fail due to foundation if everything is taken care, because it's supposed to be 3 times or more stronger than what it should be. Unless something, I don't know, is beyond our control, then I would say our foundation is not safe. Okay. So for gross allowable bearing capacity, gross we can allowable the bearing capacity, allowable bearing capacity is given by this equation, which is equal to ultimate bearing capacity over factor of safety. So if factor of safety 3, then we put it 3 here. So meaning that ultimate bearing capacity divided by 3. Let's say the soil is, I don't know what is the value, let's say 100. But we only allow it for divided by 3, maybe 33% only, the actual strength. So we lower it very low, make it very low. Since we have a factor of safety 3, for example. So Q allowable is the one that we allow for the bearing capacity. So it is much lower. Here is about 30% of the Q ultimate, ultimate bearing capacity. So it's also given here the equation. So you can use this equation, and I think it's quite straightforward. If you read this one, you should be able to understand. And then we do have example 16.1 to understand better. So we can see how they use the equations and how to use the table 16.1. For phi equal to 20, for example, we just check with the table and we get the value here. And then here, since this one is a square foundation, so they're using the equation for square foundation. And if we just continue Q allowable using this equation, and then we get 130. And then if you want to know what is the total allowable gross load, this is the load at column loads or apply on the footing. So we need to use this equation because it's square B squared, the area. So Q is kilonewton per meter square divided by the area, which is no time, because we want to know Q. Pressure equal Q over area. So area, we bring it here become multiply with the area. So Q force equal to pressure time area square here. So that is how we calculate, we know what is the allowable column or foundation load that we can apply to the foundation. Okay, and here also another sample. Here they want to know what is the size of the footing given factor of safety 3. So you can also calculate using this one. See, this is the square foundation also using the same formula. And then you can just back calculate to get the B value. Okay, I think that is straightforward. You should be able to understand if you go through it. And then, okay, just now we are talking about the Terzaghi bearing capacity equation. And now there is another equation which is a general purpose, or they call it general bearing capacity equation, and it was come up by Meyerhoff and some other researcher here, but normally people call it the Meyerhoff equation, or they call it general bearing capacity equation. It is more or less the same, except it is more general. So here I show you the difference here. They are using the angle here is 45 minus phi over 2. That is different than Terzaghi. Instead of using a phi, but they're using 45 minus phi over 2. So then the calculation, they come up making it more complicated. If I think you can read the derivation here, and at the end they have equation in the form of like this one. Okay, first they have this equation, which is quite similar with the same general form, the same thing more or less, but now they introduce depth factor, shape factor, and inclination factor. So when they introduce that, so it become like this one, the modified general ultimate bearing capacity equation become like this one. So this is the general one. So we need to know what is the lambda, CS, and so on here for the shape factor, for the depth factor, as well as the inclination factors here. And those value is given, for example, the shape factor, the equation for the lambda here is given by those equations, 32 until 34. Where L here, we need to differentiate between B and L, because normally L is longer than B. Let's say we have two value, L let's say the foundation is 2 times 4. So L is 4 and B is 2. B always less than L. L is always greater than B. So we need to check for that one also. Sometimes we may use a different one. Okay. So for the depth factors also given, and also the inclination factors also given the equation, and then you can just use the equation for calculation. And whatever before this, actually the value is for drain condition, meaning that effective stress with the prime on top of the value. So you need to find the C prime, phi prime. That is the drain condition. If you still remember the lab test for triaxial and sometimes also for direct shear, there is the phi and effective phi value. As well as C also, there is an effective C. That effective means it is under the drain condition, meaning that the water is removed from the sample. So it's in the drain condition. But for the undrained condition, this is the total stress. We are talking about total stress. If you remember, effective stress equal to total stress minus U, or pore water pressure. So if you want to calculate the in terms of total pressure, so the equation is given here. So the equation transform to this one. That is for total pressure. You may ask why we want to use the effective pressure and the total pressure. Normally for temporary work, let's say you want to do analyze for temporary works, normally we use the total stress equation. But let's say we want it for permanent, longer time. Let's say it is not a temporary work, it is supposed to be the final one. And normally that we use the effective stress. Yeah, for temporary works, we can just use total stress for total stress for undrained condition. Okay. So this is the case. I think you can skip this one, the case history and so on. But if you want to read, it's fine. Okay, so we have an example given here. How to determine the gross load, square footing. What is the gross load? What is the P value here? What is the load here? So we can use, we can look at this example problem to know how to calculate it using the general bearing capacity equation, where they are using the shape factor here. If you look here, they're using the shape factor, the depth factor, and also the other factor, the bearing factor. So this is the general bearing capacity equation, or the Meyerhof equation. So you can see you need to calculate the lambda for the depth, shape, and also the inclination factor. And here at the end we get the gross load. What is the load that we can apply to the column or to the foundation? And here 16.8, where we want to know the ultimate load for Charlie foundation under eccentric load. Okay, eccentric load. This one we are talking about here. Intensity is, for example, like this one. It's not exactly at the center, but a little bit off. So that is eccentricity. So if the load is off the center of the column, for example, and then we have to consider that using the right equation. So eccentricity meaning that it is off the the normal one. So it is off, then we can use this equation and then continue. And let's say we have a two-way eccentricity, meaning that in the x direction as well as in the y direction and x direction. So here, let's say instead of at the center here, the point of interest, the load we apply off the center. So we have the y value and x value of eccentricity. So we need to cater also in our calculation. So here giving is show you eccentricity problem. So you can look at how the calculation is being done. Okay. And then this one, 16.9, is about the bearing capacity of sand. Based on settlement. Okay. So based on settlement, what is the bearing capacity? So this is for sand. So you can look what is the settlement, calculate the settlement and so on. It's given here. The formula is given, and at the end you can get the settlement. Okay. And 16.10 is about plate load test. Normally, when we do pile or even the shallow foundation, we check whether after we install it, we check at site. After we install the foundation, we go to the site and do the plate load test to check whether the settlement is within allowable or not. So we need to do. If you look at the site, you see a lot of big stone. At site, that is for plate load test. So they apply a lot of heavy stone or concrete block, apply on top of the foundation to test whether the foundation will be okay or not, it can sustain or not, and what is the settlement when we apply the real load on the foundation. And normally they apply until double the load. Let's say the column supposed to handle only 100 kilonewton per meter square, but when they test it, they double the load, maybe 200 kPa. And then they know that the foundation strength is reliable. So it is good for the building. Okay, but yeah, this one you can read on your own, plate load test. Okay, so that would be your for the topics, bearing capacity for shallow foundation, and you're supposed to do the assignment here. I think, yeah, I already post the assignment, and then you can do it on your own. And yeah, I think that would be for this topic. Unless you like or you have any question, then we can talk. Okay, is there any question? Oh, all already gone already. Okay. Okay, is there any question regarding this topic?
No.
Okay, okay. Yeah, you can also look at the teaching video that is recorded actually for the quit student, I think last semester. So I see they are more or less the same. Okay, then I open the question about anything regarding the e-test as well as the course in general. You can ask any question because next week we don't have much time because we are going to have the e-test, and after that you are going to have a break, and then after that your final weeks. So yeah, any question?
Hi, doctor.
Yeah.
I would like to ask regarding for the lab data. Doctor say is just follow the textbook data. Can we know
Yeah.
which example data? Because
Okay.
for example, like direct shear test got a lot of examples, so it's
Okay.
better that doctor speaks it.
Okay. Let me show you. Okay, here, yeah, I think I can just look at from your. Okay, let's say direct shear test here. Okay. So here I already posted the problem here. So here, for example, for direct shear, each group is required to prepare a lab report which consists of, so you create a report with the title of introduction, procedure, lab result, calculation and discussion, also summary. And then for group 1 until 10, use information or data from problem 12.4, while group 11 until 20 use problem 12.5. So the demo for the direct shear also given here. And here, if you click the problem or the data, okay. So for group 1 until 10, they're using this one. So actually, it cut a lot of your times. For example, if you were to do the real data, actually it's not like this one, where you need to calculate. You cannot. You will not get straight like this one. You need to get the force. It's not straightforward. You need to read from the load cell there. and then you need also to know what is the area, and the end you get. For example, okay, so here test normal force is given here, and shear force also is given here, and here so this is supposed to be like the lab data. Huh? For example, you do a direct shear test 4 times, and the sample diameter is 50 millimeter. So you would know what is the cross section area, and then you need to divide here force over area, and then you're gonna get the in kPa. And then you need to plot the graph for shear stress at failure. And then you need to determine the C and phi. So yeah, this is more or less the result from the lab. Except here you cannot see at which one you get this value from. Actually, this one is from the normal force. There is a load ring attached to it, and you need to read out the value, and it's supposed to be like this one. And this one is for the shear horizontal ring or cell. From that value you read, and then you get this value. So this is the data for group 1 until 10, and this is for similar more or less, except it's different value. So this is for group 11 until 10. So you need to use this value for your calculation. The rest actually is just your to write a report. If you go to lab, this is the data that you may get. Okay. Okay. If we look at the triaxial, the same thing. There are two problem given here for group 1 until 10, and also group 11 until 20. Okay, sample problem like this one. Okay, here using the consolidated undrained triaxial test CU test, and then the sample is also mentioned. It has a 4-meter clay in the field, and estimate graphically the Morse column shear strength parameter C and phi. And then estimate the shear strength in the middle of the clay layer. So this is the result from the test, where sigma 3, the binary principal stress or the confining pressure, and this is the axial or deviator stress. So you get like this value, and the pore water pressure also given here. So similarly, if you do the test, you're going to get this more or less something like this one. But here you need, from this value information, you just need to create the estimate using the method here, using the Morse column shear strength parameter. We need to estimate that. The same thing, but here they want it graphically, so you just need to do the report, and also estimate the shear strength in the middle of the clay layer, the actual at site. At site it is 4-meter thick clay layer, but here you have only a sample, a simple one given. But actually this one cut your time because it's given, otherwise you need to measure and so on. So this is already given to you. So you can use this data and come up with the report to answer this one. So this is not like a normal lab data. Okay. And the last one about the consolidation. Okay, the same thing. We have the two problem. I choose one of them. Okay, so this is for consolidation test. And the data is given there. It's like the lab data where you have a pressure and you have the change in dial reading. Normally, when we apply, we need to know the change in dial reading. That is for settlement, and it shows there it is in millimeter. So yeah, we can see the reading there given, and then the specimen, actually you need to measure all those things actually, but here already given. For example, the height of the specimen is 20.6. The mass dry specimen 12 g. Gram area of specimen also given, and as well as the specific gravity. So what you need to do is to analyze the data. You need to plot the E logs effective stress curve, and you need to find the PC or pre-consolidation pressure from the plot, and then you need to calculate the compression index C sub C. So you just need to do like a normal report, lab report. So over there, because there is also procedure. So you assume you do the test, you look at the demo, and maybe you can read from the textbook also given the procedure, or even you can Google sometimes procedure of how to do the triaxial. So you get the procedure, and then you do the analysis and do the calculation to get the uh, uh, here the settlement, and then you plot the E log stress curve, and then the method is given in the textbook, step by step methods, and then you calculate the PC and also the C sub C. So that is your report. Okay, so that is for your lab reports. Yeah, is there any question?
Thank you, sir.
Okay, the date here I just put. Yeah, you can actually, if you do it today, you can submit it. I just put the end of July. I think 30th July. But if you need more time, just let me know. But I think you should be able to finish it because you already 2 weeks from now is already your break. So yeah, you can start working on it, or maybe you forget about it, focus on your e-test, because you have 1 week to prepare for that, and I hope within this week you should be able to come up with your assignment for chapter 13 and 16, and based on that do the reading for the chapters and be prepared for the e-test 3 next week, Monday, 2 until 4. So is that okay? Okay. Any other question?
Doktor,
Yeah.
yang lab report tu kena hantar seorang ke ataupun semua kena hantar?
One group is enough. One for one group. But
Oh,
make
alright.
sure you write the every member's name in the front page of that lab report.
Okay, thank you doktor.
Okay. Okay, if you don't have any more question, I think we can dismiss. Okay, then see you next week, Monday 2 until 4.
Thank you, Doktor.
Okay, Afwan.
Thank you, Doktor.
Okay.
Thank you, Doktor. Thank you, Doktor.
Thank you doktor.